Okay, so I know yesterday we got caught a little short on time. So I wanted to at least have a record of me going through these two examples because I think it's important. And maybe some of you were able to solve these last night in the homework, but maybe some of you might want to see again kind of that explanation because they're both really good questions. Okay, so it says find the values of x for number 7. Find the values of x where the tangent line to the graph of this given cubic function is a horizontal line. And that horizontal line is super important because it tells you exactly what kind of line in terms of slope that we're looking at, right? So the fact that it's a horizontal line, every horizontal line has a slope of 0. So that's sort of implicitly saying you need to find a derivative function, f prime, and since derivatives measure slope and we want to solve when the slope is 0, you're going to set that slope function equal to 0. So we're going to come over here. And it's just a polynomial, so it's just a power rule, right? So f prime of x equals 3x squared minus 27. So that's just the derivative. Now let's set it equal to 0. So we get 0 equals factor out the 3. And we have x squared minus 9. But I can actually even factor further x minus 3 and x plus 3. And so that would equal 0 when x is 3 or x is negative 3. So both of those instances are when the tangent line would be a horizontal line. And if you think about like what would this graph look like a cubic function. So, thinking about what does a characteristic cubic function look like, this one's going to go through 0 and also have like root 27 and negative root 27. But right here at 3 and right here at negative 3, you have the peak and trough. And at that instant, you know that that the highest point and that lowest point, there will be a point whose derivative is equal to 0, whose tangent line is exactly a horizontal line. Okay. Now, similar question. Now we want it to be tangent to this equation. And so there are two things that we have to consider when it's tangent to that equation. One, if it's tangent, right, we know that for like this quadratic here, like if you were to graph that quadratic and you graph this line 2x plus 4 or whatever, so you know that, well, that's a terrible graph, but you know that like at that instant it touches just once, so it has to share the xy point, but it also has to share that same slope, that same instantaneous rate of change. So there's two things we're going to do. First thing I'm going to do is look at the slope. So I'm going to look at f prime. So f prime of x is equal to, k is a constant, so the 2 comes in front. So 2kx minus 8. So that's the derivative at any point in time of our parabola. Now, what's the slope of this equation, or what's the derivative of that? Since it's linear, we could either just say dy dx is 2, or just know that since slope is measured by derivative and it's a constant slope of 2. So I know that these two at that instant have to match. So I want 2kx minus 8 to equal 2. Or 2kx to equal 10, or k times x to equal 5. Now, I need to find k, but the problem is I don't know x. So that's where I need that second equation. So I also know that at that point of intersection of that tangent line, they're going to share the same xy coordinate. So, oops, I thought I went to green. That's okay. So then I know that like kx squared minus 8x has to equal 2x plus 4, right? At that instant, at that moment in time. Okay, and we're trying to solve for x. So what I might do, we're trying to solve for k, but it might be easier to solve for x. I don't know, because like I know that for example, x is equal to 5 over k, and if I take that x and replace, I guess, I guess a 6 of one, half a dozen of the other. If I take that x and replace it with all of the x's here, I'll be in terms of k. that might be more work. I don't know. If I solve for k first, and k is equal to 5 over x, and I put that in just in this one spot, even though I'm solving for x, it might be easier and more efficient to do that and then go back. I don't know. I think I'll try that. So I'm going to let this k equal 5 over x, but then there's already an x squared minus 8x equals 2x plus 4. And then that actually becomes 5x minus 8x equals 2x plus 4. So then if I say 5x minus 8x is negative 3x equals 2x plus 4, subtract 2x, so negative 5x is equal to 4, so x is equal to negative 4/5. Then we need to solve for k. Well, k is 5 divided by that. So k is equal to 5 divided by negative 4/5. Well, the 5 flips over, so you get negative 25/4. So there's your k value. So again, it relied on two pieces. At that moment in time, you know that it's tangent, so it has the same slope. So we set the derivatives equal to each other. But in that moment of time, it also shares the same coordinate space, x comma y. Okay, so like I said, I wanted to walk through those two examples because we didn't get a chance yesterday. But if you have any questions, definitely let me know.